Hi, this is Silvia, and welcome to the recording of the second installment of Silvia's Brainery Live. In this interactive session that lasted a bit over 2 hours, we covered a lot of ground talking and discussing the different things that are important and considerations when you're building a model in 3D. Because it's a really long workshop, I broke it down into different segments. This very first segment, I'm going to give you an overall introduction of the scope of the workshop, as well as an overall introduction to Opensees, Opensees Pi, and Opensees Tickle. I do hope you find this recording useful and enjoy the recording.
Okay.
So what I wanted to be very specific today. I wanted to really be able to focus. So the visualization, I'm just going to show you some basic visualization. The focus here is not on visualization. It'd be neat to then have a workshop specifically on certain topics. I wanted to get started today to kind of start talking about modeling in terms of 3D frames and in terms of doing it both in Python and Tickle. I know there's a lot of workshops out there going on and everybody's doing 2D frames and in Tickle. And honestly, a lot of that is just a recipe. You can just go on. I put a lot of effort into the examples manual, and I'll go along. I'll be using one of those examples, but I feel like 3D frames get more interesting because there's a lot more consideration that I'll talk about. And then I want to show you the differences and advantages of doing it either in Tickle or in Python, and maybe convince you to kind of go down the Python route if you're just getting started, just because it's got some additional things that you can do with building your model. And I wanted to focus on a frame because it's just the simplest thing so that we can focus on the fundamentals of building the 3D model itself. And I'm actually only going to focus on using a distributed plasticity element, okay? We can then, which is, it's one line command. It's simple, and so that we can have a discussion, a more detailed discussion about 3D modeling, okay? We can then, in the future, maybe have a session on concentrated plasticity modeling, which opens up a whole different can of worms, which I think is very interesting. But I want to make sure that people have the fundamentals. What I've seen in with Opensees, I'm going to just share the screen first. I always think I'm ready and then I'm not fully ready. Okay. What I've noticed a lot of times is that a lot of users just jump in all the way to just building the model. They use somebody else's script, which is great. That's the way to go. The best way to do is to work using somebody else's script. But I think it's really important for you guys and the users to understand what the different parts of a script are, so that if you're getting errors or you want to improve it, which you should always be improving, you know what you're doing. You're not just copying and pasting bits and pieces, okay? So this is an introductory presentation, or really getting you going with Opensees, but I don't want to talk about the fundamentals or the hard fundamentals, because one is there's a lot of that you can learn just from online and the YouTube videos. I also highly, highly recommend you take my fundamentals of Opensees course. I talk about a lot of the background. I don't teach you how to build the model, which is kind of what we're doing today, but just talk about really the background and the different important fundamentals that you need in using Opensees. And also there's
Excuse me.
Yes.
Sorry. Are you talking about the videos in YouTube, or do you have a specific course on that?
So there's videos on YouTube which cover other topics. I have a special course. It's called the Learning the Fundamentals of Opensees. It's for students. It's like $250, so it's not inexpensive, but it has a lot of content. It has examples, videos of examples manual. It's got a lot of really good content that teaches you the strong fundamentals that you don't see in any of the other videos elsewhere. So this comes from the days when I used to host Opensees days, when we used to really get into the grits of understanding, especially in the analysis components, what all the different things that represent. Okay, so that's really where you're going to get the fundamentals on those. Today, we're only talking about model building. So that's another session that we can then have in the future on the analysis. So I wanted, for me, it's really important to really get these basics down? Okay, that's a good question. My objective of the workshop, this Bijan will tell you, I always try to teach you guys enough and to answer most, all your questions. But I like it when you leave with more questions, with curiosity, what's out there. Ooh, I didn't know I could do that. And it's really what I want to get in your head. Once you know you can do something, then you can Google it, you can see how to do it. But just thinking about, what these different things that you need to take into consideration. So if you walk away with more questions and answers today, I've achieved my goal, okay? Of course, I'm happy to answer all the questions, but you know what I mean.
If we were to
Yes.
have questions after the workshop, where's a good email we can contact you about those?
So it's the silviamazzoni@yahoo.com. So that's a good place to, I can answer quick questions. If you guys have interesting questions and you're building something and you really just would like to do some brainstorming, we do have, and it's an acknowledge here because that's where I learned a lot. We have an Opensees cafe where we meet every Friday morning for us, evening for you, or anyways. And we discuss all kinds of things. Sometimes we'll talk about ground motions, even sometimes most of the time we do talk about Opensees. We talk about it from a user perspective, just a beginning user perspective, or just general terms. We have somebody who does some parallel processing. So we talk about parallel processing in Opensees. So everyone brings something to the cafe. It's really interesting. And so if you do have follow-up questions that are more long-term, that's where I recommend going. Also, I'm hoping to be able to have a good discussion today through we'll have plenty of time at the end to have questions and answers as well. Okay. So I thought I was just going to cover two things today. And then as I put the outline, now I know why people write outlines. So these are the different things that we're going to cover today. I'm going to give you a just quick overview of Opensees and what the user resources are out there. We're going to talk about Tickle versus Python and the difference and the similarities. And then we're talking about things that we need to consider when you're going from 2D to 3D. There's a lot more considerations and knowledge that you need and more places to make mistakes, let's call it that. And so we're going to talk about the geometric transformation command. I know that's a stickler for a lot of people. So I want to make sure that we get through that because it's important in going from 2D to 3D. Once you understand it, it becomes trivial and then you don't get it wrong, which I think is important because otherwise the results of your analysis may not make sense. Then we're going to work through example 7 and 8 from the user manual because those are great examples. I'm going to show them both in Tickle and in Python. And then at the end, I'm going to demonstrate a way of building 3D frame that is, the one in example 8 is generic, so it's very simple script. But of thinking, since in Tickle or Python, you can write functions and loop through and program your input files, maybe it's time to start thinking before you build a model, think about how you want to move forward so that you can develop some code that you can use again and again. And then we'll have some questions and answers. Okay. Please stop me during a presentation with questions, okay? This is meant to be interactive. I could have just recorded this as a video. I wanted feedback from you to really be able to make sure that we get through this, okay? And just speak up. Don't raise your hand because I may miss it. So go ahead and interrupt me. I'm Italian, and I come from a big family, so I welcome interruptions. All right, so this is what we're going to try to get through today in the 2 hours that we have. So why Opensees? Of course, we're here. We've all been convinced about using Opensees. But what's really neat is that it's versatile. It's a framework, not a program. And because it's open source, it's not just that makes it free, but it also means it's evolving every day. But because it's evolving every day, you've got to make sure you stay on top of it, okay? And you're always learning and keeping a track of what's new, and you adapt to this. To make Opensees usable, you need a user interface. Remember, GUIs are friendly, and they're great for visualizations, and they're easy to edit, but they make it really hard to really take the most advantage of Opensees. So the fact that we've got input files and input files that are programmable, because we have an it's not just old-fashioned input lines of node this, node that, but you can actually program your input with an interpreter, these high-level interpretive languages. Now we're able to program your input file. You can have 10 analyses, 10 models in one input files. And then you can take pieces of that code and reuse them elsewhere, okay? And these are the advantages of Opensees. That's what makes it powerful. So I wanna make sure that you as a user do that and are aware of that, and don't just define all the nodes or go to a GUI. Take advantage of the fact that you can actually script Opensees. And with Python, you can kind of create your own GUI these days anyways, and just being able to visualize it. So what people think is a disadvantage of Opensees having scriptable input files, it's actually its greatest strength. Only if you take advantage of it, okay? Does that make sense? All right, don't just use the input, node 1, 2, 3. Think about and plan your model so that it becomes versatile and expandable. And so then also the other important thing is, which is the last point that I have here, because you've integrated Opensees with an interpreter, you can actually interact with Opensees during the analysis. So if there is a convergence problem, you could say, okay, let's change well, first of all, if you have a convergence problem, 99% of the time is because there's an error in your input model. Okay, your model is too weak or there's something going on, so check that. But if you have a convergence problem with Opensees at a certain time step, you manage to get started, and at some point it just can't get over, discontinuity and stiffness. What's great is you can write algorithms or adaptive algorithms, and you see those in the examples manual that I wrote, where only at this time, hey, you're not converging. Well, try changing, type of Newton iteration. Maybe try a Newton with line search. Try something, get past this point and go back to your regular method of analysis with or reduce the time step, and then keep going with a longer time step. You don't have to, oh no, I have a convergence problem. I have to redo the entire analysis using a different, integrator. You can actually change them in real time. And I've seen a lot of scripts out there, especially some of the Python ones, where they go the analysis and they try different algorithms for the entire analysis. And I don't recommend that. Okay, I recommend doing that during the analysis. But that's kind of sets us up for the next workshops that I'm hoping to have. But still, I just want you to really take advantage of what Opensees can do for you, okay? So don't just take the negative of having to write your input, take the positive of getting to write your input. Lots of online resources. There's the Opensees website. There's the wiki page, okay? In the wiki page is the examples manual that I wrote. There's a command language manual, and there's the examples manual that I wrote 10, 15 years ago. Very important is, even if you're working with the Python version of Opensees, the Python documentation is great because it tells you about the format of the input, but make sure you also go and look at the Tickle version of the manual for the same command, even though you're working in Python, because that one I had put figures and more explanations, and there's a little bit more detail in for the input, okay? So even if you're working in Python, make sure that you look at the Tickle version of the manual as a resource. Google is a great resource. There's Facebook groups and everything going on. There's a lot of resources out there for users. And also there's my website where I've put a lot of different things. And I've introduced this Brainery Bytes, which are Jupyter notebooks that are interactive, and you can use them and learn from them. So that's something very helpful and useful that I recommend going to after this workshop. Also, a lot of the questions that you may have, I may already have done in examples. Okay. This is just just within the wiki. When you go to the examples manual, make sure you go to the one that they call the advanced examples manual, which is what is shown here on the right. This is the one that I wrote, that I developed the scripts starting from an elastic cantilever column all the way to much more complicated structures. Along the way, I try to introduce new concepts and ideas. For example, something that everybody now takes for granted is using units in Opensees. Well, that was something that I brought in a long time ago because I learned it from MathCAD because people were having troubles, most of the errors were in using units and converting from one unit to another or not doing so. So I brought in the idea of using units as variables. And so you'll see that in the examples manual, how I introduce those. So I highly recommend going there, okay? So that is a resource that's valuable for all levels of Opensees users. So this is a big script, a big page that Michael Scott and I put together in comparing Tickle and Python. So what I like to do is I'm going to open this up in gallery view for myself. Can you raise your hand? So I'm going to, if you use Python or Tickle. So who here uses Tickle? Okay. Oh, I see a couple of hands. Okay. All right, so we've got one, everybody's raising at different times. Okay, so we got 4 people to, Christian, I'll take that as a hand raised. And then how many of you guys are using Python? Okay, and so Python now is these new hands. Okay, so we've got a 50-50 use of this. There is no right answer. One program is not better than the other because in terms of Opensees, the core program is in C++. Tickle or Python are literally just user interfaces. Okay, so it's just how do you communicate with Opensees? In the end, it's just formatting. And actually, what they did with Opensees Pi is they made it that the format is exactly the same. It's not Pythonic, but it's the same format as the Tickle. So you can almost just translate one to the other, and I'll show you that. And so there's advantages and, quote unquote, disadvantages for both. What I like about the Tickle version, it's a self-contained executable. You download it and you don't need to do anything else. With the Python version is great because you can always download the latest. You're always working with the latest version. And with Python, you can use a lot of other functions, okay? Tickle has the same thing. There's a lot of packages in Tickle, but it's not connected through, the cloud, the whole infrastructure of PyPy and being able to download libraries elsewhere and integrating them into your workflow as easily as it is with Python. Also, a lot of people are using Python, which means there's just new stuff coming out. There's so many new libraries, new tools. What happens, sometimes those tools break. And so there's dependencies and interdependencies that don't always work. So it's not a perfect ecosystem, but what I like about it, which is what I've highlighted here, is with Python, you can integrate a little bit better your visualization. Okay, most people that work with Tickle use Excel or MATLAB. Okay, you could do whatever you do in Excel and MATLAB in Tickle itself anyways. But plotting the graphics in TK is a little bit of a pain. And so for me, from the user perspective, being able to visualize your workflow, visualize just your material response during your analysis, really tipped the scale for me to go to Python and Opensees Pi. I like Tickle better as a programming language, but I like Opensees Pi as a UI for Opensees because it opens up a bit more features that worked for me. But sometimes it's easy to just have a package of an executable that you can run, okay? And there's a lot more examples, but I'll show you how the two languages are equivalent. And so that brings us to, the visualization. In Tickle does have TK. And also there is a tiny little function that Frank wrote into Frank McKenna, he's the developer of Opensees. There's a couple of commands he did put into Opensees. And so back then I wrote some real-time functions, Tickle functions, like the display model 3D that you will see in the examples manual. And those are great. So you can actually visualize the model, the deform shape, and the eigenvalues. And I've written them in such a ways that they're user-friendly. In Python, people have been developing packages and they keep on improving. There's OpsViz, there's a few other ones, and there's one that's changing names. And those are really, some of them are really nice because somebody else has done that for you. But these visualization packages work based on, you have to make sure that they're doing exactly what you want. And maybe you don't need something so fancy. And so sometimes you'll use to plot the deform shape, you can use somebody else's package. But maybe if you want to visualize your material response, your section response, you can actually integrate that into your own workflow. And you can do that a little bit easier with Python than you can. And so you can use other libraries as well as just do your own little functions. And with matplotlib, it's very easy. There's some really much faster plotting packages that Bijan has been playing with that are a lot more efficient than these others. So there's a whole world out there. There's a whole ecosystem within Python that is evolving every day. Okay. And so that's why, I'm pushing for Opensees Pi only if you're on the fence. If you like Tickle, stay with it. But if you're on the fence or you're thinking, and also if you're staying with Tickle, make sure you also can understand what's going on with Python and vice versa. Okay, so that's kind of the overall introduction to Opensees and Tickle and Python. Anybody have any questions on this?